calculate salinity and calculate the density. I give you the latent heat of fusion, calculate the mass of the ice cube. So experiment 2 though. Experiment 2 was the heating of the water from below. It was the convection from below. So I took a video of it, and I want to show you guys this video, but I'm going to show it to you 35 times sped up. Because in the class, it was a really boring demo. But if we actually watch what happened, it is pretty cool. Okay. Now, can you get the lights? We need the lights for this. Okay, so if I start playing, it's like really boring. Oh, we're gonna leave that. And then, but if I go up to 32 times, watch what's happening. We can see the convection, so water at the bottom is being heated, and it's slowly rising up the water column and getting higher and higher, and we can see, we can kind of see like billows that will come up at times, like over here, there's like a bunch of billows, so these are like rising plumes of warm water, but it's going so slow that throughout the class it was just like, this is so dumb. But it actually isn't. Like the video captures it pretty well of these plumes that are rising in the water column. And so we got it to rise about halfway. Oh, no, this is the other class. Shoot, I played the wrong one.
Like that didn't look like ours.
This was, I played them in the wrong order. Damn. All right, this was the 5:30 class. And the reason that theirs rose all the way at the top is because they use a much weaker stratification. I just gave away the answer. All right, here's ours. It's still really cool, ours is. Okay, there we go, and then 8, 16, 32. So here it goes, you can see the billows starting to rise.
By weird stratification, do you mean that their temperature difference was smaller?
Yeah, exactly. So on that handout I just gave, it gives the temperature, like we were writing the temperature on the board. And so this is ours, and we see these plumes, but it's like it's not being able to penetrate quite as high, because a lot more energy is needed because the stratification is so much stronger.
That's so cool.
But those plumes are pretty awesome, the way that they're rising up into the fluid, like that.
So the 5:30 class had the same exact setup?
Yeah.
So they have.
Well, no, they didn't have the same exact setup. Oh yeah, I stirred it at the very end.
Did they have the heat blanket?
Yeah, so they had the exact same setup with the same exact tank. They had the same exact heat blanket, so the same amount of heat was being added. But look at the values on this handout, the post-lab note handout. I show our class and I show their class. So we started with a 9-degree temperature difference from bottom to top. So it was much, much colder at the bottom than it was at the top. Whereas they started with a 3.5-degree temperature difference between bottom and top. So that's why theirs was able, in the course of the class, to punch all the way through to the top, whereas ours, you need a lot more heat to get through that stronger stratification of convection.
So are we trying to explain the fact that the bottom layer for theirs cooled despite having a heating blanket? And is that supposed to be from circulation?
Or would that just be measurement error? I think that's measurement error. Like why the bottom of theirs didn't heat is actually, like theirs is like the temperature at the top seemed to heat a lot more. So, take these data with a grain of salt in that they
were collected by students.
Right, with some pretty crappy thermometers. Like those thermometers, you're only gonna measure to maybe within a 0.5 degree. The bulb is like this tall. It takes a really long time for the bulb, for the temperature to change. So who knows how long students were holding it at a given level to take the measurements. I'm sure you guys did fabulously, but you know, the other class, you know, I'm just kidding. But, so anyway, I've posted both of these videos on YouTube. Unfortunately, it's really hard to watch a video sped up on YouTube. So there's two options. I've also, if you go on the Canvas site, in the lab folder, I put a little document that has links to these videos in my Dropbox. So you can download them from there and then use QuickTime to watch them sped up 32 times. Or do you guys know this trick on YouTube where if you just have a YouTube video like www.youtube.com/blah blah blah. If you just do www.ssyoutube.com/all that stuff, it allows you to download the video. Do you guys know about that? It's fantastic. Yeah. This is like the most useful thing I'm telling you in this entire course. I take that back 100%. But so if you want to download those, I've shown them just here, but you either can download them from my Dropbox, use this little trick to download them from YouTube so you can watch them sped up. And pretty much I'm asking the question, okay, it's a constant heating rate, how long would it take for our tank, the one that the color only rose halfway, how long would it take to go the entire height of the tank? Okay, and then I think the last note I made is just like, there's a question we don't have to answer because I gave it away in the lab. So, okay.
All right, I'll be right back.
Now,